A group of scientists called vitalists used to believe that life is more than simply the matter that composes it. Matter, they believed, is inherently inert, dead. It is not by itself sufficient to constitute a living organism. Vitalists have believed that some immaterial substance, some vital principle, is needed to give a material organism the spark of life. This idea has been called the ghost in the machine. Today, the old doctrine of vitalism is scientifically dead, yet in a sense it has been reinvented by scientists working on the computational theory of life, an area known as artificial life. Christopher Langton is one of the leading researchers in the field. As he explains it,
artificial life is the study of man-made systems that exhibit behaviors characteristic of natural living systems. It complements the traditional biological sciences by attempting to synthesize lifelike behaviors within computers. By extending the empirical foundation upon which biology is based beyond the carbon chain life that has evolved here on Earth, artificial life can contribute to theoretical biology by helping to locate life as we know it within the larger picture of life as it could be.
Like the vitalists, scientists working on computational life assume that matter is dead, that life can never be explained by the properties of matter. They believe that life is something immaterial, not the mysterious substance of the vitalists, but the ever-changing logical structures or forms that are encoded in the arrangement of matter. Langton says this perspective emphasizes organization rather than the matter that's organized.
It views life as a property of the organization of matter rather than a property of the matter which is so organized. Certainly life, as a dynamic physical process, could haunt other physical material. The material just needs to be organized in the right way. Just as certainly, the dynamic processes that constitute life, in whatever material bases they might occur, must share certain universal features that will allow us to recognize life by its dynamic form alone, without reference to its matter. This general phenomenon of life writ large across all possible material substrates, is the true subject matter of biology.
The forms that constitute life are like the plan for a house. The plan may be stored in our head, in a network of neurons, or it may be stored in the memory of a computer. It also could exist as a sketch on a piece of paper. But the plan is not the same as any of these three material structures. We won't learn what the house will look like by examining the brain under a microscope or by chemically analyzing the ink used in the drawing. The plan appears only in the patterns of the material structure. In other words, the plan is a symbolic object rather than a material object. But though a life plan does not materially exist, it does tangibly affect the material world. It determines the shape of the house that is built according to its specifications. Here we are echoing a view that goes back at least to Aristotle, who recognized four kinds of causes ranging from the purely physical cause up to the final cause, which involves purpose. The evolutionary biologist Ernst Mayr tells us that Aristotle understood the relationship between the eidos, or form, and the telos, or ultimate end.
Aristotle saw with extraordinary clarity that it made no more sense to describe living organisms in terms of mere matter than to describe a house as a pile of bricks and mortar. Just as the blueprint used by the builder determines the form of a house, so does the eidos give the form to the developing organism. And this eidos reflects the terminal telos of the full-grown individual.
Mayr explains that a 20th century physicist named Delbruck has shown how modern physicists have been blinded to this insight by the Newtonian framework.
Aristotle's principle of the eidos being an unmoved mover is one of the greatest conceptual innovations. The physicists were particularly opposed to the existence of such a principle, according to Delbruck, by having been blinded for 300 years by the Newtonian view of the world. And yet, unmoved mover perfectly describes DNA. It acts, creates form and development, and is not changed in the process. The existence of teleonomic programs, unmoved movers, is one of the most profound differences between the living and the inanimate world. And it is Aristotle who first postulated such a causation.
The idea of a final cause or causation by purpose seems natural in the context of human experience, but it was progressively eliminated from Newtonian science. By the latter part of the 19th century, the teleological position, the belief that life has some end or goal, had been all but banished from respectable science. But while teleological invocations of the supernatural God have been thought for over a century to be inappropriate in objective science, biologists in particular have found it difficult to live without some form of the concept. For biologists, life seems necessarily to involve plans that act as final causes. So scientists have suitably changed the name of the ultimate cause from telos to the teleonomic cause, indicating that the plans or ends are somehow inherent in the system itself. Ernst Mayr says this concept of life admits the existence of a final cause, but it does not give in to the vitalistic idea of a ghost in the machine.
Teleonomic, that is, programmed behavior, occurs only in organisms and man-made machines, and constitutes a clear-cut difference between the levels of complexity in living and in inanimate nature. Teleonomic explanations are strictly causal and mechanistic. They give no comfort to adherents of vitalistic concepts.
So the concept of an unmoved mover has in recent years been rehabilitated. It has been certified as scientifically respectable by authorities including Ernst Mayr and the British philosopher Karl Popper. 2 millennia after Aristotle, we can see that information structures, programs, and purpose have been readmitted as legitimate objects of scientific investigation.